All right, good morning, everybody, and welcome to today's G2M Research webinar. The topic is OCP 22 wrap-up, the latest and greatest in SSDs, CXL, accelerators, and other big trends for data center and cloud. So let me kind of walk you through the agenda and everything. So I'll go through the ground rules real quickly. Then we'll have a presentation from Kioxia, Astera, and Memverge. Each of those will be about 8 minutes. Then we'll have 3 panel questions. In between the panel questions, we'll have some audience surveys we'd like you to do. And then we'll have audience Q&A at the end. The webinar is being recorded, and everybody who registered will be sent a link to that recording in about 2 days, Wednesday or Thursday, depending on how quickly Zoom turns it around. You'll also get a PDF of the slide set that we're using for the webinar as well. One thing I'd like to suggest, if you have questions, please use the Zoom Q&A window to put them in. We'll go through all those at the end. And if we don't get to your question, we will get somebody to answer and get back to you. So with that, let's kind of jump into things. So if for those of you who have been going to the OCP Summit for a while, and I've been going to it pretty much ever since it started. It really started out as a pretty small show focused really on cloud scale hardware and software. This year they had nearly 60 exhibitors. That's roughly about 2/3 the number that were at Flash Memory Summit 2022. So it's a pretty good number of people. And you see not just things around cloud scale, but you see storage, compute, networking technologies all being introduced here in the show. Two of the hot areas for us were NVMe storage and CXL disaggregated memory. A lot of people in the NVMe space have been showing drives since the NVMe standards came out several years ago. It's a great place where you can see higher speed drives. Flash optimized form factors are really big as well. So a lot of the small form factors versions of NVMe SSDs were actually shown at the show last month. The other thing that there's a lot of time spent on is CXL. So CXL is a memory sharing capability. We have a couple companies that'll talk about that as we go into it. Actually, the third day of the show, there was a whole forum on CXL with a number of vendors talking about what they're doing, both on the hardware and software standpoint. There were actually 18 different presentations. So a lot of interest there, and these are two areas that over time will probably do some level of merging or overlapping. So our panelists today are Sam Badarai. Sam is from Kioxia. He's the Director of Product Management for the Data Center Division of the SSD Business Unit. We also have Ahmet Danesh. Ahmet is the Senior Director of Product Management at Astera Labs. And also with us is Frank Berry. Frank is the Vice President of Marketing at Memverge. And my name is Mike Human. I'm the Principal Analyst at G2M Research. And with that, let me hand it over to Sam. I'm going to pass you control now. Okay, Sam, it's all yours.
Great. Well, thank you, Mike. Thanks for the opportunity to talk about this excellent, exciting technologies that you provided us a sneak of. And I thank you for the privilege to talk about Kioxia's engagement on the NVMe and CXL, and look forward to this hour of discussion. So with that, just wanted to talk briefly about Kioxia and NVMe product. We have let me try to move doesn't look like my screen's moving. Let's see. Okay, there we go. We have I just wanted to present that we have, as Kioxia, have a wide portfolio of products, all the way from client, OEM enterprise, and hyperscale. For this presentation, I'm going to focus in on the topic that Mike alluded to, NVMe, and just go through a few of the products that we have that we're very proud of that we've announced recently. We range in our NVMe products that I'm going to go through. They range from 2 terabytes to 30 terabytes for enterprise and data center customers, very targeted NVMe products. We've got CM7 that you see on the screen right now, targeted at enterprise customers, dual port where it is needed. So this is a product that we're targeted for the enterprise segment. And we have single port products that I'll go through in the next couple of slides that are more targeted for hyperscale and data center customers. In terms of endurance, we go the whole gamut from endurance with drives that have drive writes per day to meet specific segments from 0.3 drive writes per day to 5 drive writes per day, and even in some specific cases, 60 drive writes per day for drives that are used for those type of things, all in the NVMe protocol. In terms of form factors, we go from all the form factors that the industry requires, from M.2 to U.2 to ADS-FF, the upcoming form factor with the E1.S, E1.L, and soon to be E3 products as well. In terms of other features, security, SIE, SED, and FIPS as needed by the industry sectors. And then also, I forgot to mention in the previous product, the CM9, we also have features like SRIOV, CMB, scatter gather for enterprise and hyperscale features like FDP, debuggability, all of those things are coming on. So very proud to go to these products. The one you see on the screen is our 2.5-inch product targeted for the data center segment. It's a single port product. You can see the details on the screen itself. And then I just wanted to briefly show the final product that we have on that I'm highlighting today. Let me see if my screen is down. XT7P. This is the product that is E1.S form factor, going from 2 terabytes to 8 terabytes in this particular case, but targeted at data centers again with the EDSSF form factor. So just wanted to give you a preview of a couple of the products that we have. Obviously, we've got products in the client and segment also that I did not talk about, but to focus on this in terms of OCP, since that's the theme of the presentation today, this product, the XT7P, supports the OCP version 2.0 spec. It has the security features and so on. So I will go through here and talk a little bit about our approach to CXL as well, the second topic that is being discussed. And from a Kioxia perspective, we believe that the combination of flash and CXL interface provides the next phase of memory hierarchy development. And what this slide shows, it's actually a build-out slide. So the bottom one you see on the gray is the overall DRAM space. And you can see the sequential or random performance and the read-intensive and write-intensive DRAM applications. And what we are proposing and working with is to segment that segment, and I'll talk about it in the next slide, where with 2 different approaches, we are in the process of providing CXL storage that meets the specific needs of application in those 2 segments. So you can see where it says CXL plus XL Flash, we propose to provide solutions that are targeted at random write, read, access, memory expansion to the DRAM space. And then for high capacity intensive use cases, we've got the CXL plus BiCS Flash solutions where we're targeting high capacity and high bandwidth for big data analytics, where all of the data is being stored in situ. For detail, you can go to the YouTube that I've got at the bottom of this page. So speaking a little bit more about what I kind of presented just a little bit in the previous slide is today we have the hierarchy, the memory hierarchy, as you can see here, with at the bottom, the hard drives with long access times and long latency, and then NAND flash and storage class memories, DRAM and SRAM being shown. As we move forward, what we are proposing with the CXL interface is to really segment that DRAM space with more solutions that are targeted at specific application use cases, so that going forward, applications can target storage/memory solutions that meet their needs. And I'll talk a little bit about that in the next slide. So you see here, this is what we believe is the future hierarchy. Contrast that with what was shown in the previous slide. And what we are showing, if you can follow my cursor, is really to offer solutions so that DRAM-like solutions that have different access modes will be able to better serve the industry with specific latency and access patterns. So as you can see here, what we're proposing is, as I mentioned in the previous slide, XL Flash-based CXL memory to target high bandwidth applications, and XL Flash-based SSD for high capacity solutions. And one thing to note is we also are working on having a compressed mode so that your data can be stored in a more compressed fashion in this solution. So you see on the right-hand side a picture or a cartoon of solutions where we are proposing a solution that is CXL based with XL Flash on the back end, DRAM, and the controller. So a solution tier that provides for higher access and higher capacity. So finally, just showing a snapshot of what can be done with XL Flash. So as you can see here in the picture in the center of the page, the gray area is the access pattern with DRAM. And what we believe is with XL Flash solutions, most of the applications that we've looked at, and the ones that we did look at are shown here: RocksDB, Aerospike, some of the high access applications that we looked at that would be very well served with a solution that we're proposing with XL Flash and CXL interface. And you can see, while it doesn't cover all of the space that DRAM does, DRAM certainly has better, lower latency and better access, but XL Flash-based solution is able to serve a very big portion of the market at a significant lower cost. So just wanted to kind of present that as a real-world use case with the CXL interface and Flash being used in a more nuanced fashion going forward.
Thank you very much. Go ahead, I'm sorry.
Yeah, I just want to hand it back to Ahmad.
Sounds good. Let me get you set. I'm going to try to put this in slide mode. Let's see if we can get that to work. 1 second here. Let me share that page. Okay, can everybody see the slides now?
Looks great, Mike.
All right, let me pass this over to Amit, and we'll let you go ahead.
Thanks, Brian.
It should be all yours.
And thank you very much for joining, everyone, and thank you, Mike, for hosting us today. My name is Ahmad Dinesh. I'm the Senior Director of Product Management at Astera Labs. So at Astera Labs, we're really focused in on solving data and memory connectivity bottlenecks in the data center. As we kind of move forward and we see this big rush of AI, ML workloads, and it's really going to be trying to drive the market as we move forward here in some large-scale data centers. So we have a lot of different products to be able to solve that, but we're really going to focus in today on focusing on CXL and some of the big discussions that were happening at OCP. There we go. Oh. So at Astera Labs, one of the big things we've been focused on is really trying to get the market there as fast as possible. When we took a look at where CXL started a few years ago, I was part of that initial launch when CXL 1.1 was first announced, and really it's come a long ways in just 3 years from where CXL 1.1 was first announced. So kind of taking CXL from that promise of what it was to the reality that we have today, and actually launching silicon and into actual real platforms. So I'll give you a bit of an overview of what we built at Astera Labs. We have memory controllers. We have our Leo smart memory controllers that are purpose-built solutions for memory expansion, memory pooling, and memory sharing for cloud servers. The reason memory expansion is so important today is we have CPU cores that have continued to increase over generation. The DDR channels continue to increase as well, but they haven't kept up linearly with the amount of cores and the performance of the CPUs and GPUs. And what that has led is memory is now a bottleneck in the data center. And so by being able to provide memory expansion, we can unlock the performance of those CPUs and start driving more virtual machines. So you increase your virtual VM density, you can increase your application density. And then on top of that, memory pooling and memory sharing is where we start to get to a full disaggregated model where we can have memory resources that are being used efficiently, whether that's from a perspective of using them efficiently from a data flow perspective, where you don't need to copy memory back and forth, and you can have multiple CPUs and multiple GPUs accessing a common memory range, or memory pooling solution where you can dynamically allocate memory to different CPUs and GPUs depending on how those virtual machines need and how much memory bandwidth or how much memory capacity they need. So to address those, we have 2 different memory controllers. One is our Leo E series that is just dedicated for memory expansion, and Leo P series that adds support for memory pooling and memory sharing for heterogeneous architectures, for multi-CPU, multi-GPU architectures. To go along with this, what we also build is our Aurora A series hardware solutions. This is a PCIe Chem form factor to make a nice, easy plug and play deployment model for a lot of our customers. But we do have a lot of customers who do take our silicon and build them into some more custom form factors that fit specifically into some of their server architectures that they're looking for as well. So if we take a look at a block diagram of how these solutions fit together, if we take a common server architecture where you have a 2P or 2-socket server, you can have memory expansion solutions where the far left-hand diagram there is showing a by 8 CXL interface. And to put some bandwidth numbers to this, a by 8 CXL interface is bandwidth matched to 2 DDR4 DIMM channels or a single DDR5 DIMM channel. And so what we can do is actually be able to throttle the bandwidth, even going all the way up to a by 16 interface, as you can see with the orange on the right-hand side of that diagram, where we can actually expand up to 4 DDR5 DIMMs. And what's interesting is because CXL allows you to separate what your CXL interface is from what your memory controller interface is we can actually support significantly higher bandwidth than what the even local CPU memory channels can support. We can be able to churn our controllers out a lot faster. And so while today's CPUs are really launching with DDR5 4800, we can actually be able to support bandwidth all the way up to DDR5 5600 as those new DIMMs are starting to come out now. The middle diagram there is what I was referring to as in the memory pooling and memory sharing use cases, where you have multiple CPUs directly connected to a single Leo P series device. And you can either share that memory where all the CPUs are accessing the single common memory range, or you can pool that memory where you can assign different address ranges to each CPU and do this dynamically throughout the life cycle of the data center. So as, for example, a Microsoft Azure or someone who's renting out a virtual machine, as they bring up and bring down those virtual machines, they can continue to dynamically allocate different amounts of memory from one CPU to another CPU. This significantly helps to reduce the actual total cost of ownership and be able to optimize the memory that's deployed in the data center. When you consider that DRAM is approximately, in some cases, about 50% of a server cost, you can see that being efficient in how you utilize that memory, as well as the performance of that memory, becomes a critical factor in the deployment of these solutions. So at OCP, what we did was show both of these use cases in partnership with some of our key customers. So we had Intel's 4th generation Xeon processors in both of these servers. In the top diagram you see on the top right there, this was actually one of our CSP customers. We were unfortunately not allowed to show what's inside the box, as a lot of that is confidential. So we pulled our card outside of the box while being able to still show this. And this was doing a memory pooling use case where we actually had the memory being allocated to multiple CPUs separately. And the bottom right diagram is what we did in partnership with Intel and Lenovo to show a memory expansion use case. This was really an impressive demo because what we showed is that Lenovo's existing SR650 servers that they're now moving over to their next generation can just easily deploy CXL attached memory with the existing PCIe chem slots that they have available anyways. And so this really makes CXL very easy to adopt. And we're kind of taking CXL from that promise of what it was to reality, delivering actual silicon that's high performance and easy to scale with a lot of the fleet management capabilities that we provide.
Okay, I'll go ahead and drive it.
So I've got a lot of slides. I'm going to go very quickly. First, and first thing I like to say is that DRAM was invented in 1969, and in the 5 decades since then, there's been multiple overhauls of IT infrastructure. The one constant has been the user experience for memory. Scarce, volatile, extremely expensive. So Memverge was founded to be part of a major infrastructure refresh, memory infrastructure refresh that's occurring in the industry right now. And the newest wave is CXL. We have been delivering big memory software for 2 years now. And by the way, our company is founded by the founders of Extreme IO and the developers of vSAN, $2 billion product lines. And we built the world's first big memory software. Big memory to us means a combination of big and fast data. So traditionally, for the last decade or plus, big data has been handled in storage, and fast data has been handled in in-memory databases. But today's applications, AI-driven applications, they need big and fast. They need to have big data sets and be able to access them very, very quickly. And storage, it can't supply the performance, and in-memory databases can't supply the capacity. And so all this new memory structure is designed to support big and fast data. We have 2 products. Our flagship software product is Memory Machine. And Memory Machine is a memory virtualization product that can give an application transparent access to a pool of tiered memory. In the last 2 years, we provided that for a combination of DRAM and persistent memory. But looking forward, we're going to add to that the capability to tier DDR and CXL memory. So the benefits of we've over the last 2 years, we've been able to prove the benefits of tiered shared memory. So this is one of our customers, Analytical Biosciences. They have a multi-stage genomic analytic pipeline. At each stage of their 11-stage pipeline, it takes them 15 minutes to load 250 gigs of data. With a snapshot to persistent memory, we can load up to 1 terabyte in 1 second. So with that fundamental capability, we were able to increase their total pipeline wall clock time, but cut it by more than in half. And you can see on the right-hand side, most of that came by eliminating IO to storage, either execution time for the code or loading data. Next slide. Another way in which the tiered shared memory can help is with by using snapshots as thin clones. So on the left-hand side of this diagram, what you're seeing is a multi-stage but single-threaded pipeline, which is very, very common. And it's very complex to transform it into a multi-threaded pipeline. But by using simple snapshots as thin clones, they can easily now transform their, and this is TGen, another one of our customers, they can transform their single-threaded pipeline into a multi-threaded pipeline, and they shaved about 36% off of their wall clock time. Next slide. Our newest product is Cloud Edition, and we've added system and cloud orchestration services. And what that does is next slide. And what that does is it allows large, long-running batch jobs to safely run on low-cost spot instances, which they weren't able to do before. So prior to this, if they put a job like this on a spot instance, they were too big to evacuate within the 2-minute warning time that a cloud service provider would give them. But with the speed of our snapshot technology, with frequent checkpointing, we can evacuate the instance, and then with our cloud and system orchestration services, we can automatically restart the batch job on a new instance. Next slide. Okay, so now let's talk CXL. Next slide. And everything is driven by data and applications. And what we're seeing is the move to CXL will be led by AI applications, which we believe will become mainstream in the years ahead. And in the areas of EDA, in 1984, the EDA emerged when chips got to 1 million transistors. Okay, we're now at 2.6 trillion transistors. And so the data sets for the super chip designs are massive. And we've seen exponential growth also in the genomics area with cell data. And just in the last 2 years, we've seen 1,000x growth in the AI models that are being run on these super chips. As you can see in the bottom right-hand side, the newest models need 100 terabytes of memory. Next slide. So why not add just more memory to handle it? Well, for one thing, it's incredibly expensive. So one DRAM weighs almost exactly an ounce. And it also costs about the same as an ounce of gold. So it's incredibly expensive to just add more memory. Next slide. And many of you have probably heard the write-ups about Microsoft claiming that their memory is about half of Azure product cost and infrastructure cost. And we did our own configuration of a single R650, and at 0.5 terabyte, it's about 52% of the server cost. And at a terabyte, it's 70% of the server cost. So it's a huge part of the compute cost. Next slide. Furthermore, today's technology, the memory is dedicated to siloed processors and apps. So just like prior to server virtualization, utilization can then be very low. Next slide. And another issue is that adding more memory may not even solve your problem if your problem is bandwidth. So with the larger DIMMs, they may saturate the DDR channels with a single DIMM. So if you add more DIMMs per channel, you may be adding capacity, but you're not getting any more bandwidth. Next slide. So the result is, just to validate what I was saying earlier, is that according to Microsoft, up to 25% of their memory is stranded. And their median VM has about 45% of their memory is untouched. Next slide. Similarly, this is data from VMware. They're saying that about 25 to 40% of their physical memory is a good fit for memory tiering, and that only 31 gigs or only 77% of, in this model, of their memory is active. Next slide. So bottom line is there's a growing gap between cores and memory bandwidth. Next slide. So let's talk about solutions. Next slide. So CXL is the new backbone of future servers. So heterogeneous XPU, any type of XPUs, FPGAs, accelerators inside the server and outside the server. So which is this new backbone allows memory to be shared and utilized at a much higher percentage. Next slide. And the end result, as you can complete this build, is we expect this to be very analogous to what happened in storage. So in the early days of disk storage, we had just a bunch of disks. And then when storage area networks were developed, you were able to share storage and really drive up utilization. And then advanced storage services were added. And we see a similar progression happening here. So we're starting out with just a bunch of memory. Now we're going to be able to pool it and tier it. And then what you're going to see is storage like advanced memory services for memory. Next slide. So this memory refresh is very broad in the ecosystem. So there's software, operating platforms, devices, processors, and all kinds of networking and memory infrastructure that's going to be needed in order for a complete CXL implementation deployment to occur. Next slide. So, and the rollout's going to occur right now. We're talking about 3 different phases in the next few years. Number 1, CXL 1.1, memory expansion. And we're going to be able to have this magical capability to not only expand your memory with DIMM slots like you see on the right, but now you're going to be able to install memory on your PCIe slots. Next slide. And this chart simply shows that you'll be able to overcome the bandwidth limitations of your DDR channels. The blue bars are showing the combination of DDR and CXL provides greater bandwidth than just any one of the two. Next slide. The next phase, CXL 2.0, memory pooling. And you'll be able to pool the memory on multiple devices and share that by the applications. And this is an appliance that Marvell is demoing, and it will be full of expansion cards, and the memory can be pooled. Next slide. And I won't spend any time on this, but here's a nice cost benefit spreadsheet that VMware put together to show the cost benefits. Yeah, because there is some trade-offs when you put memory in your CXL slot. So it does add costs, but if you can amortize that cost into multiple servers, the net result will be sizable cost savings. Next slide. And then the third phase that's in our near-term future is switched fabrics. So with tiers of CXL switches, a switched CXL fabric, you'll be able to interconnect memory in the server and memory in the appliances outside the server. And the result will be, next slide, will be eventually petascale memory. So physically, racks will begin to look like this with memory arrays within the rack, CXL memory within the servers, and big memory software that's provisioning all of these memory resources. We've talked to several end users with these massive data sets in the EDA space, in the video animation and a visual effects space, and in genomic research. And they are very excited about having a single petascale memory space so that they can load their, instead of breaking down their applications like they do now, so that people can work on separate pieces of it. Their vision for the future is that their entire application data will be in a single petascale memory space, which will really transform the speed and efficiency in which they collaborate with their applications. So we're expecting a major re-architecture of certain applications when petascale memory is available. Next slide. And then lastly, you're going to need that software. This is where Memverge lives. There are already emerging multiple local fabric. Can you go back up? What we're seeing today is multiple. The term fabric manager is out there a lot. And there's local fabric managers that are being delivered by device manufacturers. But at some point, there's going to be a layer of software needed that can communicate with all of the devices, and that would be a global fabric manager. We have another product. So our second product is a free product that you can download from members.com, and it's called Memory Viewer. And our newest version, which is available to developers and our technology partners, allows you to discover and view your memory. So you can see here that it shows a visual, it visualizes the physical topology. So you can see the two green dim slots, and down below you can see there's 4 CXL memory devices in the system. And then you can also see bandwidth utilization by process. So next slide. So as I mentioned, with our heat map capability, or heat map views, you can see by process how your memory is being used. Okay, next slide. So to wrap it up, I've got a couple of calls to action. One is, here's a link below. Join the CXL forum community. If you're a user or you're a developer, I think it's useful for you to join. You'll receive news about our newsletter about the technology, products, and our CXL forum events. You can attend our CXL forum events. We also, if you're a vendor, you are eligible for early access to our software. And then lastly, we're looking for both vendors and users that want to participate in advisory boards. So I didn't talk about our CXL forums, but we've hosted 3 CXL forums: CXL forum at Flash Memory Summit, CXL forum on Wall Street, CXL forum at OCP Summit. We've had about 20 vendors give presentations for 8 hours at each of the presentations, and they're all now available online at these links. And there's an amazing amount of information from all the leading processor vendors, all the leading memory vendors, all the leading infrastructure vendors like Astera Labs. It's a great resource. Next slide. And lastly, if you want an Endless Memory t-shirt, send me an email, include your name, title, organization, where you want us to mail it to. US only, but we'd love to get you a t-shirt. So thanks a lot for your time.
All right, thank you, Frank. Let me jump. We'll go ahead and put the audience survey question up first. Let me launch that. And while you guys answer that, we'll go ahead and do the first panel question. The question is, to what extent has your company migrated to NVMe-based storage devices? It's pick one of the above. You can use the polls window in Zoom to go ahead and do this. And while we do this, let me jump to the first panel question. The question is, the OCP Summit is specifically focused on cloud scale technology deployment, but more and more vendors see it as a general purpose trade show to introduce products and reach their targets. What lessons can the larger enterprise data center ecosystem learn from the OCP Summit? We'll start with Frank, then go, or Sam, then go to Frank, then to Ahmad. So Sam, why don't you take a minute or two? What you think?
Wonderful. Thank you, Mike. So from my perspective, the advantage that I've got into OCP, what has really stood out to me is the speed of implementation when there is real customer value that's brought forward with a collaborative environment. If you look at historically how long it's taken to make various transitions, and I'm thinking of transitions as form factors, for example, just to take that point. It has really been a Herculean effort in the past to go from one form factor to another form factor. But in this case, at OCP, with the benefit of more denser capacity or optimized power constrained solutions, the transition has been very significant, very, very fast. And particularly with the collaborative environment where there's multiple entities, both the providers, the end customers, having a voice in the thing, that's really stood out. And what I wanted to kind of address your question about what lessons can be learned by the large enterprise data center ecosystem is that when there is real value to be had, compared to what used to take standard bodies or proprietary solutions to make to implement the solution, and it would take a long time. What I've seen with the example I gave about the interface transition with the EDSFF, E1.S, E3S form factors coming forward, and also with other features like flexible data placement, a very optimized way of utilizing Flash. Those have really come into being and getting out in the world a lot faster. So that's what I would take away from that.
Thank you. Mike, what do you think?
Well, our focus on CXL, and what we see is that we're in this maybe 1 year period before CXL's systems go into production. And what we're suggesting to enterprise organizations is to work with Memverge and work with Astera Labs and to get some POCs going. You've got a year to get ahead of your competition so that when production systems are available, you might be able to establish some competitive positioning for your company. And so we're working with Astera and others to deliver POCs during the next year. We call them concept cars. So so enterprises have the ability to get a Tesla Semi or a Tesla Cybertruck from the CXL world and test drive their applications on it. And I think it might pay off because they'll be ahead of their competition.
Excellent. And Ahmad, what do you think?
Frank hit the nail on the head there. And when we take a look at the cloud and the data center that are being driven, fundamentally the way I take a look at it is there's different applications. Each of those applications have a different need in terms of how much compute power they need, how many, from a GPU power perspective, memory, storage, and networking. Each of them fundamentally will have a different need, but ultimately when we take a look at the back-end hardware, they're all built out of the same pieces. You have different types of cloud customers, whether it's someone who controls their own workload, for example, someone like Meta, who they're not really selling a service, so to speak. They control their workloads, they understand their workloads, but then you have others who, like AWS, who are just making available hardware for general purpose applications. The same fundamental challenges that they're running into are the same challenges that we're going to run into for larger enterprise data centers as well. So we're really building these building blocks that a lot of the cloud customers have driven. But when we take a look at, and Frank touched on it, there's a lot of people who are contributing to the CXL ecosystem, both in driving the specifications. We see a lot of the enterprise customers who are actually on the board of directors as well for CXL. So it's fundamentally the same problems that everyone's trying to solve. And we're going to see this inflection point in this next year here as CXL starts taking off. So right now is that time where a lot of the cloud customers are getting ready to deploy with the solutions. And a lot of the enterprise customers are starting to build these solutions. So this is the time to start getting engaged, building those POCs, building that hardware, and fundamentally running the different applications on them to see which type of hardware, which amount of memory bandwidth versus capacity is best suited for each type of application.
Excellent. Thank you very much. Yeah, I've found the OCP Summit's really matured as a show, and it's pretty interesting to see where it's going. Let me launch the second question, panel question, the poll question. And that question is, what do you believe is the approach for your company to deploy CXL-based memory infrastructure and networking? This is a multiple choice question, so you can check as many as you want. It's not a one choice only. So go ahead and take a few minutes to do that. And while we do that, we'll go to panel question number 2. And that second panel question is, CXL brings the promise of disaggregated software-defined memory to computing, similar to how NVMe and NVMe over Fabric did the same thing for flash storage roughly 5 years ago. Do you think that CXL will push changes in how memory storage or how NVMe storage is deployed in the data center and cloud? We'll start with Frank, then go to Amit, and then go to Sam.
Okay, give me a second. I'm reading it here.
No problem.
Wow, that one's a tough one. Well, I think eventually, I mean, this is related to this whole subject of POCs. I mean, we're as anxious to work with enterprises to flesh out, these lines of demarcation for the different media, for the different tiers. I don't think anybody knows yet. I think once we start deploying, starting with POCs into these application environments, then there's going to be a natural, lines of demarcation of which media and combination of media makes sense.
Excellent. Ahmad, what do you think?
Yeah, well, I'll actually answer this by expanding it a little bit further as well, right? And we touched on flash storage, and being disaggregated the last 5 years. But really, we started off with, very cold storage tapes, and then eventually SATA solving, HDDs, and then eventually SSDs, and SAS came around for HDDs and SSDs, and then NVMe came around. So this kind of idea of storage tiering has been around, and that disaggregated model has been solved quite well. What's amazing about CXL is that it is the de facto standard for all memory tiers. And so as we're starting here, the most in demand right now is, hey, we want to put more DRAM. We need high bandwidth. We need more bandwidth. We need more capacity. But memory tiering is going to become more important over the next few years here. And NVMe definitely does have a space here to be able to sit behind a CXL interface as well. And I think Sam will probably have a little bit more to touch on it based on what he was discussing as well. So I think CXL is really going to change this paradigm of taking a look at what type of media should I connect behind CXL, whether that's high performance DRAM, whether that's some type of persistent memory, or some of the emerging memory technologies that a lot of the memory vendors are working on. CXL starts to allow to standardize that. You can have a memory controller that connects to any type of memory. And of course, it could connect to NVMe storage as well for creating a different type of memory tier. Excellent.
And Sam, what do you think?
Yeah, so I agree with what Ahmad just said. And just to add to that, at Kioxia, we believe that the combination of flash to CXL interface will enable, as I mentioned, as I showed in the pyramid, the next phase of memory hierarchy development. We expect that the CXL would change the hierarchy such that you can apply the targeted memory signature that is more congruent with your application and provide with solutions a much better, richer offering. Right. So by applying flash to CXL memory, we see the opportunity to meet the demand for large capacity memories seen in the need in the market. We have two approaches: the CXL plus XL flash, as I showed in the presentation earlier on, to cover the random read-write using low latency flash that we have, XL flash. And then for large capacity solutions, using CXL interface with BiCS flash, so specializing on sequential read applications, particularly using BiCS flash, standard BiCS flash. So we envision in module SRAM cache, compressed DRAM tier, and XL flash tier. So solutions. So the tiers are going to be, by combining these, we expect to augment DRAM, what are being used today only by DRAM, with much better, lower cost solutions. One additional thing to note that I forgot to note earlier is that thanks to the SSD-like architecture of XL flash-based memory, we can compress more user data, which further reduces the bit cost, right? Not only for XL flash, but also for DRAM tier in the module. So yeah, we are very positive on the potential for this type of solution.
Outstanding. Now I'd like to launch the survey. This is also a multiple choice one. And the question is, what do you see as the biggest hurdle to large scale deployment of CXL-based memory solutions? And while you guys answer that, we'll jump to the third panel question, which is, with CXL and NVMe being the dominant storage and memory connects in the reverse order in the data center, and with them both running over PCI Express, how do you see these standards merging and or becoming complementary over time? Ahmed, we'll start with you and then go to Sam and then to Frank.
That's an exciting question. I think it will probably take some time for these to merge. There's definitely space for each of them to coexist, and I think they will be coexisting for quite some time. CXL, when we take a look at the actual protocol, there's three sub-protocols. The .io protocol is actually essentially the same as PCIe TLPs. And so you could theoretically have an NVMe storage device that just supports CXL.io and presents that, but NVMe has grown a lot. There's a lot of adoption there. There's a lot of, even from a management perspective, there's a lot already baked in there. Reusing a lot of that investment that a lot of companies have put in is going to be important as we move forward. So can the two merge over time? Potentially, but it's going to have to take a lot of investment to be able to potentially merge into different management capabilities. And since a lot of that has been standardized, it will be potentially challenging for them to kind of merge together. I think they will be complementary when we take a look at the types of devices that are being managed and the way that both from a CXL consortium perspective and the other consortiums, we're all trying to standardize. We're all working with DMTF. We're all working with SNIA to take a look at how these devices are managed, fundamentally leveraging the PCIe physical layer and providing different protocol layers, either PCIe Express protocol or CXL protocol from a data path perspective, is going to continue for quite some time. And we're all just going to leverage a lot of the existing standard bodies for managing these devices. So I think it's going to be more about being complementary over time rather than merging over time.
Excellent. Sam, what do you think?
Yeah, I think Ahmed said it very well. I think we certainly see it being complementary. And what we do see is, provides, as I mentioned, more nuanced use cases where, people would select the right approach in addition to what I showed about the memory usage in terms of the NVMe CXL working together in a complementary mode.
Frank, you get the last word on this one.
I guess I only have a rhetorical comment and as probably answering a question with a question, but I wonder if storage class memory might be a catalyst for, them merging. So if these hybrid products with memory combined with NAND take off, then maybe that might be a catalyst for them to merge.
Good point. And with that, let's jump to the Q&A section. So we have one question, and that is, are all three companies attending or showcasing SC22 this week? Sam, Sean would like to jump in and answer that on your guys' side. So Sean, if you want to go ahead and answer that one. I guess we lost Sean.
Sorry, Mike, once again.
Yeah, the question is, are all three companies attending or showcasing SC22 this week?
Yeah, so I can only speak for Kioxia. Kioxia doesn't have a booth on the show floor, but we do have a few people out there, mainly ecosystem folks.
Got it. Let's see. How about Astera Labs? Are you guys at SC this year?
Yes, we are. Yeah, we're excited to have, similar to what I showed in the other slide earlier, we've partnered with a couple customers to showcase their hardware, specifically Supermicro and Lenovo. And for the first time ever, we're also showcasing AMD with their latest EPYC processors. So AMD just did their launch last week. And so we're excited to actually show an AMD-based platform at SC22 this week as well, showing a memory expansion use case.
Excellent. Frank, I believe you guys are here as well, if memory serves correctly.
I'm sorry?
I believe that Memverge is also here, and the CXL forum spaces?
Yes, I'm not sure I understand the question.
The question was, is your company showcasing SC22 this week?
Yes, so we have a booth there, and we have a demo station in the CXL Consortium booth.
Perfect. All right, that was it for the questions. Again, thank you, Ahmet. Thank you, Sam. Thank you, Frank, for sponsoring this webinar. And thank you all the participants for being a part of it. As I said at the beginning, we'll be sending out a link to the recording, as well as a PDF of the slide set in the next couple of days. So hopefully you'll join us with more of these in the new year. And thanks again for your time, and have a great day.